Hi, I'm Warren Yates at yatesbanjos.com, and today I'm going to try to teach you a little bit about how to turn a tone ring. Okay, let's first look at where we're going to start and where we're going to end up. Now, I will not be able to supply technical support, but I can possibly supply you in a casting of one particular alloy that I plan to offer. So let's first off see what we're going to do here. Okay, this is a raw casting that you would turn your tone ring out of. And once it's turned and plated, and of course you can see how it loses a lot of weight and becomes a machine surface all the way across the board. And looking at the other side of it, you can kind of see where it resembles a tone ring a little bit. So it's in there, it's just simply carved to where it's at, and you've got a tone ring. What I'm going to recommend to you is a formula that was very common back in the 50s and has been very common even today. It's a standard off-the-shelf material. Basically, it's nicknamed 8535 or 85555, which is 3 fives together. What we're really saying is 85% copper, 5% zinc, 5% lead, and 5% tin. Now, as far as coming up with a way to do the casting, let me forewarn you that it's something you might not want to get into. I didn't know what I was getting into when I got started. I'm glad that I did, but if I had it to go over again, I would probably back out of it. The equipment gets very expensive. It's very hard to learn. And if you have somebody else to do it for you, then you're going to be subject to the quality that they give you. Trying to change formulas is extremely expensive with minimum quantities that everybody has to reach. If you do, more power to you. I suggest that you not. Just in my opinion. Let's take a look at some of the tools that you're going to need. You're going to need a set of 12-inch calipers to start with to be able to measure thicknesses and to be able to measure all the way across an 11-inch tone ring, and to be able to reach inside to be able to get that measurement as well. This is my lathe that I use. It's a regular machinist type lathe. It's not anything extremely expensive, but it does have to be of a certain quality. You have to have a chuck that you can mount on your machine that will accept some factory made pie jaws. And the way these pie jaws come is you order them specifically to the type chuck you're buying. They're much bigger when you first put them on there, but what happens is you get them mounted and you number them and so that you know where they were designed to be. And these jaws always stay with that chuck. You never use that chuck for anything else other than the one thing it was designed to do, which is to hold those jaws. With those jaws, basically you would lock something in the center, whether it be a socket or a piece of pipe or something like that, of what you feel is reasonable with some experimenting. And then you turn on your own lathe the size diameters that it takes to be able to grab the different items that you need to be able to grab. And once you do that, then you take the ball or the pipe or whatever you got inside there out of it, and then when you squeeze it out to the size of the unit you just made that size, it fits perfectly. And if you're into banjos, you're going to need one of these machines to be able to turn your rims anyway, so you know you need something that'll be a true asset to your business. I guess one of the biggest questions is, how do you grab one of these tone rings to be able to turn it? And what I do is I turn to the inside, and up under this part here, I catch it there and mount it over where my rim would go. Okay, you can see that I have my casting mounted on my jaws, and the inside of a casting is not the greatest of accuracy because it's simply mashed against sand, and if there happens to be a bump, it's going to come out. So you've got to find a place that it seems to most comfortably fit. And being I had this turned for 9.5 inch inside of a rim, it's not going to fit exactly the inside of this. So what happens is it's rigid enough that I can grab it like in this small section here in 3 places, and I can get the outside turned to a surface that's good and round. When I flip it over, then it will be accurate and it'll be thinner, and I can go ahead and carry it on to the next thin weight. Now, my tool of choice is a carbide tip piece that's changeable, and you notice it's got to be as small as you can get it, because these machines are just not strong enough, as well as with the material being thin. You can't gouge the material or it'll chatter and you'll tear up something. At the same time, you want everything on your lathe where it's quick change and easy to remove, because you may go from one process to another. But in this case, this one tool will cut everything that a tone ring needs. Okay, now safety is definitely something that you have to keep in mind, because when you're throwing these chips, you don't want them thrown back in your face, and that's exactly where they're going, and just simple safety glasses is not enough. Now I have a light mounted so I can put a little light on what I'm seeing. I've got a shield made in a very primitive way that I can bend it down and I can look through the window and be able to cut and keep myself safe. Okay, now if you keep your machine clean and no other type metal products, and certainly not sawdust, you can actually resell the shavings that you pull out of the machine. But it can't have any kind of metal debris or anything like that, or they devalue of what you get. Unfortunately, you pay for the material to start with in dollars, and you sell the scrap by pennies. But you can't melt it down and redo anything, because it introduces too much oxygen and impurities and that kind of thing, and it's just simply not worth it. You'd never get enough in there to melt it one time do you any good. I'm going to start turning this, and we're going to see what it takes to get the first part of a tone ring turned. I don't know how many RPMs that is, but you just kind of have to play with it and see what you get. Now I have an automatic feed out, so I'll give it a little more, and I'll do an automatic. It cleans it up a little bit better. Okay, this is where you start using your calipers. You find a place where you're as wide of a point as you can be, and to reach that 9.5 inch measurement on the inside, it looks like I need to go another 115 thousandths. Now you don't want to guess at it, and you don't want to have to keep measuring to death, so what I do is I've got a digital readout. That's all it is. That's a very good economical brand. First off, I've got it set on radius. I need it on diameter because I measured all the way across. So you see my D pops up. I'll zero it off. Now I can turn it 115 thousandths, and I'm to the measurement that I need. Of course, I don't trust myself, my calculations, or my machine, so I'll get close to it and I'll measure again. Okay, it's time to measure it one last time, and I am to my measurement. Actually about 2 thousandths over, but that's fine, it doesn't matter at all. So now we're going to change our position and start cutting the outside. Now the good thing about this type of tool is I can turn it to where I've got just enough to reach this outside and then crank it out to it. Okay, and at that point I'll turn it around a little bit by hand because I don't want to cut off too much at one time. It just becomes too hard on the tools. This is going to go back in my face, so I'm going to turn my safety key on. I'm going to crank it in a little bit by hand, I give it some more feed, and then I turn it automatic from there. And you repeat this process until you're down to your 11 inches. At this point, I've cut some of it where I can kind of see that I'm down through the casting area. Now I can use my calipers again to measure across the outside. And it looks like I've got about 11 inches, 35 thousandths. So basically, I'll go back and zero off my digital readout, and I'll move in about 25 thousandths, and then I'll double check to make sure that 10 more thousandths is where I need to be. And let's get one more measurement. And I have just a little bit, at about 3 thousandths that I can take off. So I'm going to run a very light pass across it so that I can get just as smooth of a surface as I possibly can to keep the cleanup from happening. So I like to zero off my machine, back it up just a little bit, go past it, put it back on my zero, and then do a final pass with no pressure on the tooling. Now, as it happens to be, as I finish up that pass, I end up in the right spot to be able to cut the straight across portion of that ring. And I'm going to have to put this down to be able to pull that off. Okay, you see where it starts to square off. Okay, now I have to reset this area here so that I can now go in and cut the area inside there, that angle. So basically you use your degrees here on the side, and normally I set it around, I think I found 39 degrees to be about what it needs to be. But there again, you have to experiment on your standard of what you think that your tone ring needs to be. Just because I do it a certain way or someone else does a certain way does not mean that it has to be that way. This is your project, you set the new standard. Okay, and from here, I spin my chuck, make sure I don't break a tool off. I'll turn it on, and I just simply have to manually turn in order to pull it off until I get down to the thickness that I want it to be. Now this area here is going to square off a little bit, but that's fine. We've got our radius we've got to come back and put on it anyway. Now I've gouged out quite a bit of it, down to the point that I need to be very careful to my light cut. Very careful in order to clean that area up as clean and smooth as I can possibly get it. fan of CNC cutting on a tone ring, because if a machine is designed to go to a certain spot and cut, and it's going to do that regardless if things are right or wrong, then there is no human ability at that point to go and say, stop, I'm fixing to mess up, or I need to watch for this. It's simply one size fits all, and the end product can be drastically different. By hand, you've got full control. You can decide how you're going to do it, and if a dull tool gets involved, you don't ruin a product and then find out after it's all done. Okay, now every surface on this side of the tone ring has been turned, except we need our radius across here. That's going to be determined, how big that radius is determines how much of a flat area that you've got. So you'll have to work out how thick that's got to be and what kind of radius you want and all that. Some tone rings have big radiuses, some of them have little sharp ones. You know, this is your product, you're the boss on this situation. Now, in the past, I have ruined many files going along here and filing this to be able to get what I've got to have. And of course, there's every opportunity with a manual lathe like this for you to get seriously hurt. All machinists that have been doing it for years have to remember to stay afraid of their machine, because it's ready to get them at any minute and to hurt them. Make sure you can't do that. If I were to do this and happen to get caught up into this and have this thing run through my stomach, there might not be any more Yates Banjos. So I have to find better ways to do this. I made up a tool, and basically it's a carbide tool that I use that has a little bit of a radius on one side, one on the other, and it's not so much of it's not like I can take that radius and just push it into depth. You can't do that, because as I've said before, these machines won't hold up to that much chatter. You have to go in there and move it back and forth and gradually cut a little bit out at a time, and if you start to chatter, stop. That's as far as you can go. So I'll set up to where I can go in here and at least get it started and see how far I can go. So I'll cut a little bit on the outside. Now back and forth. And then we'll get this done. I'll pull it out and reach in and get the outside, inside just a little bit, just to kind of keep it round. Difficult to do this operation and not have the shavings come back on me. But you have to be able to see it, and you know, I can't use a shield to do that. Okay, so if I needed at that point to clean it up a little bit with a file, I could, keeping safety in mind. But you can get to the point you don't have to do that, and I didn't, but I wanted to show you just in case. And you can see there's a little bit of a roundness to it. But the machine is not as, the part is not as refined as it needs to be, and we're going to finish it right here. My tool of choice here is to use an orbital sander with 600 sandpaper, because I'm going to sand the surface of this while I'm here, and I'm going to sand it so slick there's no need to buff it anymore. Now I'm hoping that you can still hear what I'm doing, because I've got a vacuum machine going, the sander's going to be going, and my lathe is going. This stuff is going to be broken down at this point to where it can be breathed. You do not want this in your lungs. Put your cell phone up, anything that could be contaminated with metal dust, get it out of the area. Wear a mask. Keep it ventilated. As you you can start to see it's starting to shine a little bit, but I see grooves in there where my lathe did not totally pull them out. So I'm going to keep going until they're pretty well gone. It looks like they're about gone now. I need to work on the inside just a little bit. Only the radius part of it. Okay, at this point, I don't use the air spinning the tool anymore. I simply hold it to get all the scratches going in the same direction. It starts to shine up immediately, but it's just a trick of reflecting light. It's basically what a polish is. Okay, so basically the outside part of the tone ring is finished. Now the inside is still rough casted, and we can get rid of our exhaust at that point. So now we're going to take it off and we're going to mount it the other direction. I'll show you how that goes. You see it's still very thick, so you can see how that type of hold would work. But you still check it periodically and make sure something hasn't worked loose on you. Okay, now that the inside of the tone ring is machined perfectly to 9.5 inches, well, the area that I designed to be 9.5 inches will now perfectly fit that unit. So I can put it in there and now tighten it up on it. So now I am perfect to the outside shape, so I can start cutting off the inside. So we'll reposition our tool here just a little bit to be able to hit those areas. Now I've turned my machine back straight to 0 degrees, and I'm going to turn my tool where I think that I can hit most of the surface areas. And of course I'm going to have to move it in close to make sure that I can go across all ranges to be able to hit the surfaces that I need. So I can go beyond it, and I'm going to be careful not to cut into my chuck. The thing is, I don't know at this point how far I've got to go in order to cut that to depth. So I'll show you how I measure that. First of all, once I've got my tone ring set up to where I can clamp it, I take it back off and I'll go over to my tool, a good solid location, and I'll bump the tool into the part. I'll reach up and set my depth at 0, which is my axis going this way. And then I'll pull it back and then remount the tone ring. Now, what I've now set up is to where I'm measuring from the top of the tone ring out to wherever my measurement comes on my machine. And, you know, you'll have to take a tone ring that you feel like is the best size and shape, and to figure out what that measurement is from the top to where it sits down on top of the rim. Okay, so again, one more measurement and I'm there. Okay, one more surface has now been cleaned up. Now at this point, you've got to decide whether you're going to make a short skirt or a long skirt, or to whatever standard that you're looking for. In general, in today's terms, Short skirt is 3/8 or 0.375 from this edge to the outside edge. That's 3/8. And long skirt is 400 thousandths. So you decide what you're going to do, and basically you let your readout tell you where it is. So when I come off of this measurement, I'll zero. Then I'll come back out to the desired measurement that I want. And of course I can't cut it all at one time, but I'll go back and I'll start cutting a little bit off here, and I'll watch my indicator until I'm to that level, and then I stop. Okay, so now I have one more surface and one more dimension cut. And I made this one 0.375 for a short skirt. Now I've got to go in here and cut out the inside. Now that's where it becomes a little tricky. Now, the idea is that all of these castings be sandblasted so that you don't have the sand from the mold on there. And but you're using a carbide tool, but it's still no match for sand. So while I've got a little bit of a dull tool in here, I'm going to use that to cut the majority of the bad stuff where sand could be located out. Then I'll put a new tool, a new insert in here, so that I can guarantee to not try to bend this tone ring. When you get into this thin edge here, it's going to balloon out like making a cymbal if you're not careful. So you've got to make sure that it cuts rather than rubs. So let's go ahead and see if we can dig some of that out. Now, I've cleaned up the inside of it. My tool seems to be cutting fairly well. I'm not building up any kind of heat or anything right now, so I'm going to see if I can go just a little further. Now, here's something where the art comes into it, and you're going to have to figure this part out so that it's your product. You know that on the inside here, I said I set mine at 39 degrees. You know, who's to say that's correct? It's the way I do it. You might want that inside lip parallel to it. You might want it at an angle. You might want it rounded. There's every shape in the world that you may come up with and think that is the way to go. The only way you're going to try it is take the chance on ruining a ring and try it. If you come out with a gold mine, then do it again. That might be just what it is. And it may be just okay, and if that's what you're looking for, that's fine too. See what happens. Some of the best things in the world happen by accident. So if I'm going to cut it by a certain measurement, a certain degree, I'm going to show you how to do that. Now, it's difficult to get the camera where I need it to be and still be able to run the machine, and to not mess my camera up by throwing metal chips all into the electronics. So I'll do the best I can. So I've got my axis set to where I've paralleled it with the outside. I've used 39 degrees there. I'm not saying that's right or wrong. It's the way I'm doing this one. Now I'll go in by hand. So I'm set to the depth. I'm moving around a little bit until I can figure out where I need to be. Simply manually moving it inside and out. If it gets to where it's hogging too much material, you better ease off and cut little amounts, because it will chatter. And it can chatter enough to totally lock your machine up and snatch the tone ring out and throw it at you. Be careful. Okay, let's say you're at this situation and you've managed to cut to the depth that you're looking at without getting killed doing it. So now I'm going to take my calipers again. I can measure inside here and see what measurement that I come up with. And of course the measurement you come up with is going to be your design, so take notes so that you know what you did in case you decide to repeat it. So I'm going to cut out just a little bit more. Now this is my first attempt at maybe saying that the tone ring is finished cutting, but I don't know that. But I do know that if I take it off the lathe, it might not center up be exactly in the same place. So make sure if you take it off, don't move anything, check it, put it back on there in the same place, and the odds will be that it will still be as round as it was when you started. But I take a piece of sandpaper and I'll go in and I'll hit these sharp edges because you can't have that on there. Now let's see, I'll check it by weight and see what I've got. Okay, I just put it back on the machine. I checked it by weight, and even though weight might not be everything, it is important. And I'm about a half a pound too heavy at this point. Well, that's fine. I can take more off. I can't put more back on if I've gone too far. So I have to decide where am I going to cut it. Well, I have my measurement here that I believe is correct. I have my measurement in here that I believe is correct based on how I want to do this ring. The only place I can take it off is going deeper. And then make sure and feathering my edges back out where I go, and then put it back on the scales. And I think most people agree that in the neighborhood of 3 pounds makes a good ring in most cases. So that's what I'm going to shoot for on this one. Okay, I weighed it again, and I'm about 3 ounces over my desired amount. I'm going to make this a no-hole ring because, so I have to allow the weight in there of the holes if I want to be that precise. Adding the holes takes off about a half of an ounce, so I'll go ahead and go all the way to the 3 pounds on this one. Okay, I made some more cuts. Let's see how I stand on weight. Okay, I just got through weighing it. I'm exactly at 3 pounds, so right or wrong, it doesn't matter. That's how I wanted mine. So I'm going to use a rubber hammer. I'm going to tap it and just see if it sounds like a tone ring. I think it sounds like a good tone ring. Well, we just completed a tone ring that is all the way down to a buff finish, yet no buffer has ever touched it. Let me give you a little bit of warning about buffing. If you decide that you want to buff one on your own, it's fine to buff the outside and to buff here. If you try to buff this inside here, the buffer will take it away from you. You'll tear your tone ring up. You'll get hurt in the process. And if you'll notice, people typically don't spend a lot of time buffing, and that's why they got hurt somewhere along the line and said that is enough. I'm not doing it, and I won't either. But we do have to drill the hole in it because the neck has to mount through it. So you don't want to do that by hand, because what happens is we've got a fragile piece of material right here now. And if you were to take a drill and a drill bit, it's going to catch, and you can't really hold it back. So what I do is I take a center drill. Center drill is what a machinist would use to start a hole with. And what we do is it has a little small bit that gets started, and then it's got a tapered bit that comes down, and it kind of almost like reams it in order to get it the rest of the size. I have a machine set up that only does one thing and one thing only. So if you don't have to reset up every time, then it's to your advantage. Okay, I've got my little machine here. And I don't think one spot's any different than the other. So I put it on, it goes to depth. This machine never changes. I've got my center drill in here. That the shank up here at the top is the right size of the hole for my standard. I'll get it started very easily. Okay, I'm through the first portion of the hole, and I'll ease down to the next one. I was able to hold it back, didn't have any kind of a problem. Now I've got a very good clean hole cut through there. No cracks through it or anything like that. Well, I think you can see that we've got our new turn tone ring that started from a casting. It looks very much like the tone ring that I have over here that's plated. Now if you get into plating, that is a whole different thing. And again, good luck with figuring out how to do it to make it even look halfway decent. It's not the easiest thing in the world. Yet sending it across country to have somebody that knows nothing about a banjo, possibly, to cut on your tone ring and plate it is a very scary thing. But it can be done. It's done every day by different makers. You just have to pick your people and express what to do and what not to do. You also have to be careful that if you have somebody to pour your rings, your castings, that they're not associated with somebody else that builds banjos, because if you end up with something you don't want known, secrets don't stay secrets long. So, you know, you may have your process, and it may simply be put it on the machine, cut it, and go. Or it may be that you have to wait till the dark of the night when no black cat has passed and you have to walk around backwards for 3 days before. I don't know what it's going to be, but whatever you come up with, you don't tell anybody. That's your trade secret. And if you do something odd that makes you have an advantage, or it makes you feel better about it, nobody can tell you that it's the wrong way. And if they do, then tell them, okay, well, make a banjo that sounds better than yours, and they'll generally change the subject. So, I hope this was very educational to you. And as far as the one particular formula, it's a very good formula, 85-555. I can supply those castings to you and save you a lot of trouble in trying to make tooling. One thing that you will run up against is if you were to try to find a foundry that will cast things, they expect you to have your own tooling, and that's not something so easily to come by. There's a lot of art in the kind of tooling that you use, because you've got shrinkage to take into consideration. You have to know that once the product is done, that it's light enough that you don't end up spending all of your time and wear and tear on a lathe to be able to cut it back off. Not to mention the cost of the raw material to be able to have to throw away due to using up carbide inserts and everything like that. So my castings are down to a very minimum size to help you to get a good clean product very quickly. So anyway, that's it for tone ring making, and I hope that it helped. And if you don't decide to get into it, then that's fine. At least you've seen another process that maybe you haven't before. I'm Warren Yates, yatesbanjos.com. Come check us out and see what we do.